Okay, so comparing what we just did on the previous one to this one, now what I've asked is I asked a sample of 14 couples how much they spend. So I've classified how much the boy and the girl spend. So there's a big difference between what we see on this one and what we see on the last one. On the previous one, it made no difference which boy was with which girl, right? These two were independent from one another. This boy did not go on the date with that girl. This boy did not go on the date with that girl. I could switch these values around and the data would be the exact same because all I'm analyzing is the x bar of the boy and the x bar of the girl, okay? But when I ask couples, now they're no longer independent from here to here. And you notice I just switched it just to make life a little bit easier. But now the data would change if I switched it around. Like, look at these group. This couple, they were ballers, right? Spending $500 and $424, so they must have went all out. Versus this one, this couple spent spent some less money, or this one. So the data would change now if I switched these boys around, right? Now we would see that the male here spent more than the female, and this difference would be different. So I no longer have independence from here to here. And I can always ask myself, what did the data change if I switched the values in one of the rows? And yeah, it would in this scenario. So I don't have independence. So if I don't have independence, that was one of our conditions for a two-sample T. But notice what I did here. I subtracted all of these values. So even though I had a sample to begin with, how many samples did I actually have? We actually really only have one sample of 14 couples. So that's the difference here from what we did before. Before I had two samples. So I'm no longer going to analyze the difference of the mean of the girls and the mean of the boys. I'm going to find the mean of the differences. And so this actually leads us back to our regular old one sample t-interval. We just call it a matched pairs t-interval. Now you might say, why is it called matched pairs? Because guess what design this is? This is a matched pairs design, right? So I selected couples and asked the boys and the girls. So we need to be on the lookout. Now remember, matched pairs does a good job of reducing variability for us, so we like that. Okay, so let's go ahead and go through phantoms. This is the true mean difference. So that's what I'm interested in this time. Alright, so first thing we need is what are we interested in? So we're going to let mu d now. Okay, so what is mu d? So mu d is the true mean of the differences between how much a boy's true mean of the difference between how much a girl and a boy spent on Cosby prom. So now instead of the difference of the means, I'm doing the mean of the differences, and that's a little tricky. Just make sure you think about that a little bit. Okay, so let's start off with our HO. So HO in this one will always basically assume that the differences are equal to 0, that males and females spent the same amount. My HA is the mean difference spent by Cosby different to 0, so mu d is not equal to 0. Okay, so that's what we're going to start off. Conditions are all the exact same, just like we did before. Okay, so the conditions are the exact same as a one sample. They're no different. Okay, so we have a random sample of 14 pairs. Okay, so we have a random sample of pairs. And independence we're going to kind of leave out. Now I need independence between the couples, but not within the couples, and that's tricky. So we're just not going to get too specific on this. And then we need to check normality. So what do we talk about with normality? Hey, look, these differences, right? So a normal probability plot of the differences shows a linear pattern. So we can assume the population of differences is approximately normal. Alright, so there we go. So we can see that now, instead of having to analyze both of them, we just analyze the differences and we're good to go. Alright, so let's name the test. So this here is our matched pairs t-test. You could also call it a one sample t-test for differences. Okay, so you could do that as well, depending on which name you want to go with. Alright, our test statistic is not anything special. It's still the t-distribution we're talking about means. So now instead of just putting x bar, we put x bar d for the differences. Instead of mu, you put mu d for the differences. Instead of s, you put sd for the differences over the square root of n. Now my degrees of freedom are my number of couples minus 1. So we had 14 couples, so my degrees of freedom would be 14 minus 1, which would be 13. So just make sure you note that. Okay, so let's go ahead and grab some values here. So our test statistic then, and I've got to go to the calculator to run this. So I've got it in here, girl, boy, and I did the differences. Okay, you just type the differences in. And notice menu, stat test. Notice there's no match pairs t-test. Because guys, mathematically it's no different than a t. So we just run a regular old t-test. We just know as the statisticians that it is based off of the differences, not the individual values. Okay, our null hypothesis was 0, and we had the list and the differences. And we want to prove that it's not equal to 0. Alright, there we go. Whoa, test statistic is 7. Whoa, p-value 0.008, and 13 degrees of freedom. Wow, alright, 83.5, 44. Alright, let's try to fill this in. So 83.5, and obviously that makes sense, right? Look how far away 83.5 is from 0. 44 over the square root of 14. Test statistic was 7.1. Wow, so that's pretty far away, right? And so remember, what that means is if this is 0, here's 7.1, we find above, and then we also find below negative 7.1 because it was a two-tailed test, two-sided test. Okay, so my p-value is 0.000000008. I don't know if that's right, close enough. What alpha level? What type error would be fine with? It's not that big of a deal if we say males spend more than, if it's different when it's not, so we use 0.05. So this is less than 0.05, so we do reject HO. And when we do reject HO, we therefore have statistically significant evidence. That the true difference, that the true mean difference in amount that all CHS boys and CHS girls spent on prom is not 0. Okay? So therefore, what can we say? Now a quick little confidence interval on the end will give us something to say. So we'll just run our confidence interval, and guys, it's the exact same thing as a one sample. So menu, stat, confidence interval, and I just do a t-interval. Again, as statisticians, we know that we're talking about the differences, and I just do it for the differences. Okay? And so I believe it's between 58 and 108. So we're confident that the true mean difference lies in the interval 58 to $108. And there we go. Okay, so quick recap. How do I know this is matched pairs? First of all, do you see this identifier of couple? That needs to be our first clue. Like, whoa, why would they tell us that we see this couple thing here? Right? Why would they give us this header if it didn't matter? Okay, so that's our first clue. Number 2, we see that this girl is not independent from that boy. They are connected, they both are dating, right? So they might both spend more or both spend less depending on what they wanted to do for prom. Okay, so that's the next thing. How do we analyze it? We analyze it with the differences. Okay, we also ask ourselves, could I switch this value and this value? Would the data change? Right? Would the data change? Yes, it would change because the difference would change. All right. How is that different than two sample? Well, first, two sample, notice I have different sample sizes. So how could it be matched pairs? It can't be. So that's one clue. Number 2, it's two random samples. There's a RAM sample boys and RAM sample girls. So the only reason that these two are next to each other is just pure coincidence. Would the data change if I switched this one and this one? And the answer is no, it'd still be the same X bar. So that's our big difference between our two sample and our matched pairs.